Gravity, in the context of fermenting alcoholic beverages, refers to the specific gravity, or relative density compared to water, of the wort or must at various stages in the fermentation. The concept is used in brewing and wine-making industry. Specific gravity is measured by a hydrometer, refractometer, pycnometer or oscillating U-tube electronic meter. The density of a wort is largely dependent on the sugar content of the wort. During alcohol fermentation, yeast converts sugars into carbon dioxide and alcohol. The decline in the sugar content in the presence of ethanol drops the density of a wort. The percentage of alcohol can be calculated from the difference between the original gravity of the wort and the current specific gravity of wort. By monitoring the decline in Sg over time, the brewer obtains information about the health and progress of the fermentation and determines that it is complete when gravity stops declining. If the fermentation is finished, the specific gravity is called the final gravity. For example, for a typical strength beer, OG could be 1.050 and FG could be 1.010. Several different scales have been used for measuring the original gravity. For historical reasons, the brewing industry largely uses the Plato scale, which is essentially the same as the Brix scale used by the wine industry. For example, OG 1.050 is roughly equivalent to 12 degree P. By considering the original gravity, the brewer or vintner obtains an indication as to the probable ultimate alcoholic content of his product. The OE is often referred to as the size of the beer and is, in Europe, often printed on the label as Stamois 1/4 LZE or sometimes just as a percent. In the Czech Republic, for example, they speak of 10-degree beers, 12-degree beers, which refers to the gravity in Plato of the wort before the fermentation. Terms related to gravity: specific gravity is the ratio of the density of a sample to the density of water. The ratio depends on the temperature and pressure of both the sample and water. The pressure is always considered to be 1 atmosphere and the temperature is usually 20 degrees Celsius for both sample and water, but in some parts of the world different temperatures may be used and there are hydrometers sold calibrated to, for example, 60 degree Fahrenheit. It is important, where any conversion to a degree P is involved, that the proper pair of temperatures be used for the conversion table or formula being employed. The current ASBC table is meaning that the density is measured at 20 degrees Celsius and reference to the density of water at 20 degrees Celsius. Mathematically, this formula gives the true specific gravity that is based on densities. Brewers cannot measure density directly and so must use a hydrometer, whose stem is bathed in air, or pycnometer weighings which are also done in air. Hydrometer readings and the ratio of pycnometer weights are influenced by air and are called apparent readings. True readings are easily obtained from apparent readings by. However, the ASBC table uses apparent specific gravities, so many electronic density meters will produce the correct degree P numbers automatically. Original gravity. Original extract. The original gravity is the specific gravity measured before fermentation. From it the analyst can compute the original extract, which is the mass of sugar in 100 grams of wort by use of the Plato scale. The symbol will denote OE in the formulas which follow. Final gravity. Apparent extract. The final gravity is the specific gravity measured at the completion of fermentation. The apparent extract, denoted, is the A degree P obtained by inserting the Fg into the formulas or tables in the Plato article. The use of apparent here is not to be confused with the use of that term to describe specific gravity readings which have not been corrected for the effects of air. True extract, the amount of extract which was not converted to yeast biomass, carbon dioxide or ethanol can be estimated by removing the alcohol from beer which has been degarded and clarified by filtration or other means. This is often done as part of a distillation in which the alcohol is collected for quantitative analysis but can also be done by evaporation in a water bath. If the residue is made back up to the original volume of beer which was subject to the evaporation process, the specific gravity of that reconstituted beer measured and converted to Plato using the tables and formulas in the Plato article then the T is. See the Plato article for details. Te is denoted by the symbol. This is the number of grams of extract remaining in 100 grams of beer at the completion of fermentation. Alcohol content, knowing the amount of extract in 100 grams of wort before fermentation and the number of grams of extract in 100 grams of beer at its completion, the amount alcohol formed during the fermentation can be determined. The formula follows, attributed to boiling, where gives the number of grams of alcohol per 100 grams of beer, that is the ABW. Note that the alcohol content depends not only on the diminution of extract but also on the multiplicative factor, which depends on the OE. De Klerk tabulated Balling's values for, but they can be calculated simply from P. This formula is fine for those who wish to go to the trouble to compute TE, which is only a small fraction of brewers. Others want a simpler, quicker route to determining alcoholic strength. This lies in Tabriz Principle, which states that the depression of specific gravity in beer to which ethanol is added is the same as the depression of water to which an equal amount of alcohol has been added. Use of Tabriz Principle lets us calculate the true extract of a beer with apparent extract as where is a function that converts Sg to a degree P and its inverse, and is the density of an aqueous ethanol solution of strength by weight at 20 degrees Celsius. Inserting this into the alcohol formula, the result, after rearrangement, is which can be solved, albeit iteratively, for as a function of OE and AE. It is again possible to come up with a relationship of the form. De Klerk also tabulates values for. Most brewers and consumers are used to having alcohol content reported by volume rather than weight. Interconversion is simple, but the specific gravity of the beer must be known. This is the number of cc of ethanol in 100 cc's of beer. Because ABV depends on multiplicative factors as well as the difference between OE and AE, it is impossible to come up with a formula of the form where is a simple constant. Because of the near-linear relationship between extract and in particular because the ABV formula is written as if the value given above the corresponds to an OE of 12 degree P, which is 0.4187, and 1.010 can be taken as a typical FG, then this simplifies to with typical values of 1.050 and 1.0104, respectively, OG and FG. The simplified formula gives an ABV of 5.31% as opposed to 5.23% for the more accurate formula. Formulas for alcohol similar to this last simple one abound in the brewing literature and are very popular among home brewers. Formulas such as this one make it possible to mark hydrometers with potential alcohol scales based on the assumption that the FG will be close to 1, which is more likely to be the case in winemaking than in brewing, and it is to vintners that these are usually sold. Attenuation, the drop in extract during the fermentation divided by the OE, represents the percentage of sugar which has been consumed. The real degree of attenuation is based on TE, and the apparent degree of fermentation is based on AE. Because of the near-linear relationship between and a degree P, specific gravities can be used in the ADF formula as shown. Brewers Points. Many brewers like to exploit the near-linear relationship between and a degree P to simplify calculations considerably. They define, call it points, or brewers' points, or excess gravity, and use it as if it were extract. The Plato degree is thus approximately the points divided by 4. As an example, a wort of Sg 1.050 would be said to have 1000, 1.050-1 closing round bracket equals 50 points, and have Plato degree of approximately 50 quarters equals 12.5 a degree P. Points can be used in the ADF and ADF formulas. Thus a beer with OG 1.050 which fermented to 1.010 would be said to have attenuated 100, 50-10/50 equals 80%. Points can also be used in the SG versions of the alcohol formulas. It is simply necessary to multiply by 1000 as points are 1000 times. Software tools are available to brewers to convert between the various units of measurement and to adjust mash ingredients and schedules to meet target values. The resulting data can be exchanged via Beer XML to other brewers to facilitate accurate replication. See also: Plato's scale, gravity. References